Hello, Alan here. Purpose of this video is to look at a technique that I've been using for a number of years to improve the joint appearance when building gavels specifically, but anytime we try to mate two curved surfaces together with a tenon separating them, and we try to minimize the amount of the tenon that peeks through, and I've illustrated that with some reflective tape. So this would normally be the configuration that most of us have learned over the years in the realm of gavel making as to how to get it done. And that's perfectly acceptable most of the time, but I kind of figured it'd be interesting to see if we could find a way to get rid of that tenon area there. Maybe that would be a way of improving the appearance and even potentially making the joint a little tiny bit stronger. So in that context, I've got a fixture, which we'll talk about in a few minutes, that we can use to basically dish out a section of the hole that we've drilled in our gavel head in this case. And we've tried to make it conform to the shape of, in this case, a bead that we've got. And hopefully, when the joint is complete, the tenon disappears. So that's sort of our goal. Also, I found it in fact, I learned a long time ago that it's really a good thing not to necessarily drill a hole for the handle's tenon before you even start turning the head. I like to do it basically after the entire piece or head piece has been finished. But that comes along with all kinds of problems. I mean, one is you have to be able to center the hole evenly. You also have to make sure that the center line of the handle is exactly 90 degrees from the center line of the head. And that's kind of, it's challenging. It's not so hard when you have square stock, but when everything is round, it gets to be a little bit more challenging. So what I'd like to do is show you a little fixture that I put together a while back that kind of helps deal with all these problems. So the fixture that I developed a while back is comprised of some real simple parts, and in effect it's really more of a specialized set of jaws for your favorite vendor's scroll chuck. And in this case, I'm using a kind of one of the original Nova chucks. I've removed the standard metal jaws that come with it, and I basically crafted two jaws, forming a set, so to speak, with some scrap stock. Actually, I had turned a complete circle and then cut out these pieces. Drilled some appropriate holes, okay, in each one of the jaws that match the hole pattern in the chuck so that this whole thing can be expanded or contracted as needed, depending on the size of the gavel head, in my case, that I was looking for. Also, I put in padding, and this is kind of important because we want to make sure that when the gavel head is inserted, we want to be able, first of all, we want to protect it because presumably it's been finished at this point. And we want to make sure that we can move it back and forth, so kind of traverse in X and, along whatever we want to call this particular axis. And then also some rotation like this and some rotation like that. But whenever we get the whole piece configured the way we want and locked in, then in order to keep it there, especially while we're drilling the hole, which is one of the important things, we put a little lockdown plate, if you want to call it that, just made out of some thin plywood. And what that does is it locks the gavel head in place, and it also gives me room later on to use a gouge and literally to come in and develop the shape that I need to match that first bead on my gavel handle. Okay, so what I've done is I've used my trusty P-Touch label maker, and I've basically done a label that is nothing more than a bunch of white space with a single large dot or a period that I can use as a target. And the whole idea is that as this piece is rotated around, if I have perfect alignment, in other words, if my drill is going to go directly into where that dot is and right into the center line of the gavel head, then when this thing is spinning, that dot should basically be stationary, like right dead center, okay? And what I've purposely done is I've offset it a little bit just by rotating the barrel head of the barrel of the gavel head, and you can see that that dot is precessing around. So I'm really not at a point where I could drill in and make sure that the hole is going to end up where it needs to be. So what I need to do is make an adjustment to try to bring that dot, that target, into a better spot so that my hole will be drilled in the correct position. And let's see, this might be a little bit better. I've got to make sure that I've got the gavel head seated in my jaws. And let's see how we did here. Well, that's a lot better. Not perfect, but much, much, much better. In fact, maybe if I could do, let's try one more iteration and see what happens. I have a couple of marks on the head. I'm sorry, on the jaws. I don't know if you can see there's one here, and they theoretically would mark the kind of the perfect center line, and you can see that my dot isn't quite aligned with them. So let's see if we can maybe make use of those marks. They're not extraordinarily exact, but they should be close. So let's rotate just a wee bit. Well, there we go. Still not 100% perfect, but probably well within the limits of the accuracy that I'm trying to achieve. So that's kind of the basic notion, I guess, of the combination of the fixture and the piece and the geometry of how things fit together. And one thing that I also found pretty early on was that no matter how tight I pressed my gavel head in, when I came in with a drill, especially a big diameter or large diameter drill like this one, okay, once it got in, it would tend to pull the gavel out of the fixture. So what I did was I basically crafted, just out of some scrap real thin plywood, a little hold down system that get this real. Wait. When this is here, it is capable of locking the gavel head in. Make sure that it doesn't come popping out. And it actually serves multiple purposes, as you'll see when a little bit later on, when I actually do everything that we've seen on a real piece. Let me just kind of. Okay. So with this retainer clamp on there, there's no way that gavel head is going to be able to pop out, which is really, really important. Also, you can see that I've actually put a kind of a recess in here, and if life were perfect, if it needed to be perfect, I'd spend a little bit of time aligning this lock so that the hole here is has the same center as my target dot. But it turns out it isn't necessary to do that, to do the recess that I need to do or want to do in the gavel head. But there you can see the whole thing kind of rotating around. Now, just a couple of important addenda to this whole process. One is that anytime you've got a fixture like this with big openings and something that's not made out of robust materials like metal, you have to make sure that you never, ever, ever get your fingers or any other body parts or clothing parts anywhere near this part while it's rotating. That's like incredibly important. So safety is the most important thing I can think of. In fact, if you're not being safe, then the rest doesn't matter because you'll hurt yourself. So that's sort of the long and the short of the fixture. Now, what I'd like to do next is I'm going to actually work this exact process with a gavel head that I'm developing or have developed for one of my customers. So here's my target right here, and it's exactly centered between my little pyrograph grooves and also out to the end, each end of the gavel. So I'm going to go through exactly the same process, so you'll see that. And the one thing you'll see in addition to that is hopefully I'll drill my holes, actually one diameter than the 5/8 final diameter, and we'll also take a peek at the process of developing that recess for the first bead of the gavel handle. So we have the undrilled gavel head inserted back or in the fixture. This happens to be made out of sapele mahogany, and I have a target, which you can see very, very nicely right there. It's actually a little hole that I punched in, and it's centered equally between these two pyrographed grooves. And I've got the whole piece set up so that the entry point for the handle is going to basically be exactly centered between the two ends of the gavel. I chose to measure the diameter of the gavel head, which is a little over 2 1/8 inches. And I want to make sure that the tenon and the hole that I drill doesn't go so far that it'll go all the way through. So the tenon on this particular handle is approximately, and it's just shy of 1.5 inches. Okay, so what I have done is the first bit, which is I think 15-30 seconds, So this is sort of the pilot bit, if you want to call it that. I put some reflective tape on right here where I've got 1.5 inches between the tape, and this is very important, and the tip of this brad point bit.
Call from Baltimore, MD.
Oh, call from Baltimore, MD. How about that?
Call from Baltimore,
Rotate this
MD.
around so you can see it a little bit better. There you go. You know, whenever you use a brad point bit, you have to remember that there's a tip out here that you have to factor in, because you don't want to have the measurement kind of to the first part of the drilling area, and then have the tip go all the way through. So you got to remember, 1.5 inches total. Okay. And I've reconfigured my lathe so that I have the ability to kind of get the drill in close without extending it too much. There we go, something like so. There we go. And also, I need to, in fact, I'm going to pause just for a moment because I need to put my retaining lock on there. So I shall be back in a few moments. Okay, so I'm back. And as you can see, I've got the headlock in place, and actually I was able to center it up a little bit better than what you saw in the earlier part of the slideshow, or the video. I'm not doing PowerPoint anymore. I got to remember that. And anyway, at this point, we're ready to start drilling our pilot hole. And I'm going to kind of clear the decks here, make sure I got everything out of harm's way. And let's see if we can get this thing started. See, the tip of that brad point went right into that little hole that I had in there. So far, so good. There's the customary squeaking that we always end up. Okay, and right there, you could see that my little reflective tape contacted the surface, so I know I'm right where I need to be. Okay, I'm going to stop the lathe. Let's pull the tailstock back a little bit so that I can extract that pilot bit. Oops. There we go. And I'm going to go for my 5/8 inch bit. Not a brad point, by the way. It's just what I happen to have, and actually this is a much better bit for this particular job. Okay. Get that nice and tight. Bring the tailstock up a little bit. Lock it in place. And I have to go and get some reflective tape and also make my measurement to make sure I don't go through the barrel. So it looks to me like right about there is the correct depth. And it turns out when I do these gavels, you don't have to be perfect because you can always come back later. And if you happen to not go in far enough, you can shave some or just sand some material off the end of the tenon to shorten it a little bit. Okay, so it should be good to go there. Actually, I'm going to lock that in. Okay, let's see what we can get done here. Okay, there we go. Right there. You can see how the chips built up on the bit there. Okay, stop that. Let's back off the tailstock a wee bit. Oops, sorry about that. We're, at this point, finished with the drilling. So we can stow away all the drilling-related parts. All right. Okay. So the next step is to get the curvature adjusted so that it matches that first bead in the handle of the gavel. Okay, and also I need to do a test fit here to make sure that I've got all of my diameters correct. And if you bear with me, I'm going to pause the video just for a moment because I'm going to pull my tailstock out of the way and do some adjustments here just to make sure that we're ready to go. Okay, so I've reconfigured my lathe a little bit to get ready for this last step in the process. And I guess the very important notion is that you need to be able to do a little test fit of the handle into the hole to make sure that the handle diameter is correct and the depth is correct and that everything fits together appropriately. So that's what I'm doing now. And everything looks pretty darn good, actually. Okay. Actually, I think I'm bottomed out a little bit, so I might end up shaving a little bit of material off the end of the tenon. But what I want to show you is that if you look very closely, you can see a little bit of the tenon poking through right there. And again, the whole point of developing the fixture and this process is to make that as small as possible. To me, that gives the overall appearance of the gavel a lot more finished and professional appearance. So one important note that I had forgotten about, since I haven't done this in a while, when you do your measurements for the length of the tenon and the depth of the hole, if you're using a bit like this one, you have to remember that it's tapered at the end. So you have to make sure that the taper on the end of you have to remember to put a taper on the end of the tenon that comes close to matching this. That way the handle will go in completely. If you don't do that, it'll actually bottom out somewhere, elsewhere on the bit, and that's not good. That's not what you're trying to achieve. So I made a correction to the tenon on the handle, and we should be good to go for that last important step. So what I'm going to do is bring the banjo up. Oops, make some adjustments here. There we go. In the tool rest. And this is the part of the process where everything, kind of comes together or comes apart, depending on how accurately you do your turning. So, in order to get this recessed area developed, you could probably do it a whole bunch of different ways. What I'll probably end up doing, I won't start with a scraper, although I could, and I'll just kind of real lightly. Actually, I think I am going to try it with this. I do have to bring the tool rest up a bit. And you do have to remember, since as this thing spins around, you're going to get wood, air, wood, air. So it's very, very similar to turning a natural edge bowl. You have to take all the same precautions. So let me at least make a little trial cut here and just see how well this does. I guess I didn't mention it earlier, but it's also important not to go too fast because the fixture is liable to fly apart. So you have to be aware of that. I'm making light cuts. See. Okay. And already you can, I hope it shows up, you can actually see how we've got some material being removed here and none over on the sides, which is exactly what you want. And even at this point, if I don't have enough room now, actually. Yeah, what's the easiest thing to do? Let's skip that. And already, even with that little bit of stock removal, the bead is sitting closer to being flush than where we started. So long and the short of it is we're not removing much material. Okay. Now, how do I know that the curvature here matches the bead on the handle? Trial and error. I've done it enough times where I kind of get a feel for what I need to do. But if you can figure out a more precise way of doing it, please let me know. I'm always open to suggestions. So you can see that I've got that recess widened a little bit. And that's looking better. Not quite perfect, but it's darn close. So what that suggests is that the shape that I've developed there in that recess is pretty close to matching the shape of the bead. A little bit further. Okay, that's looking pretty good. Test fit. Just want to take a closer look at the gavel head and handle that we've been able to join with a conforming groove in there. I'll take it apart there just so you can see the groove, or the recess maybe is a better word, and they fit very, very nicely all the way around. So this particular gavel will have an engraving done on the head, and when I get the piece back from the engraver, I'll use glue, put everybody in a clamp, let it dry overnight, and I'll have a completed gavel set, or gavel singular. Also, I want to mention that this is a process that can be expanded in a lot of different ways. And in fact, here's a big hammer that I built once upon a time. And sure enough, I used exactly the same process in exactly the same fixture, now without the retaining clip, so I had to be a little bit more careful with it. But I achieved the same result, where I got a really nice joint between that first bead and the in this case, the hammer head, which is very, very nice. It also gives it a little added bit of strength. Not much, but a little bit. So I hope that this presentation has been of value to you. Please let me know if you have any ideas on how to make it better, or if you have any other information that you'd like me to pass on. I'm delighted to hear from you and also to assist you. Thank you so much. Have a wonderful day, and keep on turning.